In this video, we're going to do some practice problems for double displacement reactions. So let's start with the first one. Notice there's no acid base, so we know this is going to be a precipitate type. The metal will kick out the other metal, the switch bots basically. And so now we're going to have, so this is lead with chlorine. It's lead 2. So we have PbCl2 plus strontium 2 with nitrate. And you're going to crisscross strontium 2 plus with nitrate 1 minus, and you get NO3 2 here. And remember the rule, nitrates are soluble, so they will be aqueous, and the other one must be the precipitate, the solid. Then you can check to make sure if it's all balanced. It looks like everything is balanced here, so we are good to move on to the next one. Okay. So once again, it looks like we have a double displacement that'll be producing a precipitate, and that's because we don't have any acid or base. So the metals will switch bots. The aluminum goes with nitrate, copper goes with the chlorine. We have copper 1 because nitrate's 1 and there's no subscripts next to it, so copper 1 and chlorine together makes CuCl plus aluminum goes with nitrate. Aluminum is plus 3. Nitrate is negative 1, so we get that there. Remember, nitrates are aqueous, and the other one must be solid. And then you could try to balance it afterwards. So it looks like we'll need a 3 over here. It looks like we'll need a 3 over here. And now it is balanced. Just like single displacement, double displacement reactions won't always happen. There are some cases where we put no reaction. That's something you'll learn in grade 10. But for now, in grade 11. But for now in grade 10, we're going to assume that everything we're doing sort of just happens, because we're learning the general rules first. Okay, next one. Once again, no acid, no base. So this is just a precipitate type. The K and the Ag will switch spots. We get some AgCl plus some K with nitrate, KNO3. Nitrate is aqueous. The precipitated forms is the AgCl. Okay, now we're getting into something a little bit different. Notice we have our base, and this is our acid. The metal switches spots with the hydrogen. And so we get our water, which is H2O, that's always produced, right? Plus the compound, the salt that forms between sodium and bromine, which is the crisscross between sodium and bromide. Na plus, Br minus, aqueous there. And then you can check to see if everything's balanced. And it looks like everything is balanced. 1 O, 2 H's, 1 Na, 1 Br, done. And so this is your salt over here. This is the water. This is the acid. And this over here is the base. All right. Next, we're going to try the last one. Once again, notice there's an OH, there's a base. There's an H there, acid. So metal will switch bots with the hydrogen. The hydrogen goes with the OH to get some H2O. And then the copper goes with the Cl. It's copper 2 because we have a 2 up here, and the hydroxide's 1. So it's copper 2 chloride. So CuCl2, that's your salt. It's going to be aqueous, and your water, of course, is liquid. You can try to balance it after to see if it's not already balanced. And it doesn't look balanced to me because we have 2 chlorines here, but only 1 here. So I got to put a 2 here. Now that gives us 2 chlorines. Total of 2 H's plus 2 H is 4. So we're missing some H's. So I think I have put a 2 here. So now it's 4 H's, 2 O's, 2 O's. Yeah, now we're balanced. 1, 2, 2, and 1. And now we have our balanced neutralization equation between copper hydroxide, which is our base, copper 2 hydroxide, I should say, and hydrochloric acid, HCl, which is our acid, to make water, and then our copper 2 chloride, which is acting as our salt over here. In future lessons, we're going to learn about acids and bases in more details. Right now, at least you're able to recognize what a base looks like, what an acid looks like, and then later on we'll learn the chemistry in more depth. We've already seen neutralization, which is something we'll do a lab about later on after we do our acid-base lessons. So for now, you should be able to identify double displacement reactions, predict products, and based on the type, tell me if there's a precipitate or a neutralization. So if you could do all these practice problems with no mistakes, then you're good to try a few problems in the worksheet, not that many. You can just kind of move on there. If you made a lot of mistakes, didn't get any one of these right, you need to go back and review the lesson, retry these until you can do them without any mistakes at all, without even me doing it. And then you can go to the worksheet and try a few more problems.